let's see how we're doing with the mole stuff. Just 4 more. Okay? Write them down and give them a try. Okay? And then I'll give you a few minutes and we'll do the first one. I'll give you a few minutes and we'll do the second one. Okay? Remember, you got the mole equation here and you got Avogadro's number. Both of those are on your formula sheet, don't forget. Okay? All right, so question number 1 is a type 1 question. Okay, we're being asked to find the number of moles. Okay, so we're looking for N. We're told the material is calcium carbonate. Okay, so we're going to go 40.08 because we have 1 calcium. How many carbons do we have? Just 1. Yeah. Okay, so we'll go plus 12.01 plus we have how many oxygens? 3. Okay, so 16 times 3. Okay, so we're going to put those together and then we'll get the molar mass. Okay, so 40.08 plus 12.01 plus 16 times 3. Okay, it gives us 100.09 grams per mole. All right, and the other thing they tell us is we have 125 grams of that, so that's little m, that's mass. Okay, so if we want to find N, we just have to plug those two numbers into the mole equation. Okay, so 125 divided by 100.09. Pretty sure that's going to come out to 1.25 moles. Okay? Everybody all right with that one? Okay. How many people have done the second one? Okay, let's look at the second one too then. Okay, so on this one here, type 2 question, we're being asked to find the mass. Okay, so we're looking for a little m. Okay, they tell us that it's lithium phosphide, right? So we'll have our 6.94, that's our lithium, times 3, plus 30.97, that's our phosphorus. Okay, put those together. Okay, so our molar mass should be 51.79 grams per mole. Okay, and we're also told, sorry, the number of moles. Okay, 2.7 moles. All right, that's what we've got. Okay, we know we're going to be using this equation here, but now I've got to solve for little m. So I want to leave little m where it is because it's on top. Okay, I want to solve for things when they're on the top of an equation, and I'm going to move big M over to this side by multiplying by it. Okay, so we're going to go big M, okay, times N equals mass. Okay, plug in our numbers. So 51.79 grams per mole times 2.7 moles. Okay, the moles are going to cancel, and I'm going to be left with grams. Okay, and that's going to be 139.83 grams. Okay, questions on that one? All right, I'll put the other questions back up on the board here. Okay, working on 3 and 4. Remember that 3 and 4 are going to require you to use Avogadro's number. Okay, now as a quick review, there's only 2 things we ever do with Avogadro's number. We either multiply by it or divide by it. Think about whether you're looking for a big number or being given a big number and wanting to make it smaller, and pick the appropriate mathematical operation. Okay, so I'll give you a few more minutes on those. Okay, so for number 3, we are trying to find the number of molecules. All right, so I'll put that in my givens. Number of molecules is what I am looking for, okay? And they tell me that I am dealing with iron 3 oxide. Okay, so 58.55. 55.85. Always get it backwards. Okay, 55.85. Okay, and there are 2 of those, so that's my 2 irons, plus 3 oxygens, so 16 times 3. Okay, so 55.85 times 2 plus 16 times 3. All right, so 159.7 grams per mole for my molar mass. And they also give me the mass. They say I have 230 grams of iron 3 oxide. All right, now I need to get number of molecules, but I can't get that directly. What can I find right now directly? Moles, yeah, I can find the number of moles. I can find n because I have little m and big M. Okay, so n equals little m over big M. So I'm going to take the little m that they gave me, 230 grams, and I'm going to divide it by the molar mass I calculated, 159.7 grams per mole. Grams are going to cancel, and I'll be left with moles. Okay, so I have 1.44 moles. All right, I'm keeping all those decimals in my calculator, remember, okay? They're going to be important because I'm going to multiply that very little number by what? By a really big number, right? 6.02 times 10 to the 23. So all those decimal places, believe it or not, make a difference, okay? We're talking about a gigantic number here. So the next step, because I realize that number of molecules is a huge number, I know I'm going to take n and I'm going to multiply it by 6.02 times 10 to the 23, right? So that's going to be 1.44 times 6.02 times 10 to the 23. Okay, on my calculator, that's going to look like this. So I'll take that number, multiply it by, in brackets, remember Avogadro's number always goes in brackets, 6.02. Okay, second function, hit the comma button to get the E, 23, close the brackets. All right, so I will have 8.67 times 10 to the 23 molecules. Okay, question?
How would you know when to use Avogadro's number?
Anytime molecules are involved.
Okay.
So if they ask how many molecules, I have to use Avogadro's number to get that because that's the number of molecules in a mole. If they give me the number of molecules, I've got to get back to moles. I need to use the number of molecules in a mole to get back to moles.
Okay.
So anytime molecules, like number, is given or wanted, Avogadro's number is involved. Okay? Any other questions? How many people are done 4? Okay. I'll give you a couple more minutes on number 4, okay, and then we'll go over that one. Now, there is a little bit of a trick with number 4, so in case you're looking at 4 and going, I must have done something wrong, is this number here, 5.42 times 10 to the 21, a lot smaller than Avogadro's number? It is. So is it okay if you get a very small number when you do this? It is. Okay? Those are the kind of questions you can ask yourself. If you get a number and you're looking at it, you're like, oh, that doesn't feel right. Well, then kind of just walk it through in your head. Should this be a small number? Should this be a big number? Okay. Okay, let's have a look at number 4. So in number 4, we're given the number of molecules. We're asked for mass. That's type 4 questions. Okay, you get the number of molecules, which is huge. Okay, and you're trying to find mass. Well, in order to find mass, you need to have the number of moles and the molar mass. The molar mass we can calculate right now because they tell us the material. Okay, so I'm going to write that mass is an unknown. Okay, I have the number of molecules. Okay, it's 5.42 times 10 to the 21, which is really small, like on the order of 100 times less than a mole. Okay, somewhere in there. And I have the material, so I'm going to find big M. All right, nickel 2 nitrate. All right, so nickel is 58.69. Okay, how many nickel in this one?
1.
Just 1. Okay. And how many nitrogen in this one?
2.
2. All right, so 14.01 times 2. And how many oxygen? 6. All right, 16 times 6. All right, 182.71 grams per mole. Okay, I need to find mass and I don't have N, and I need it. All right, but if I understand what I have, I have the number of molecules and I also have the number of molecules in 1 mole, okay, I should be able to use those two numbers together to get the number of moles. Number of moles, big number, small number? Small. Number of moles is going to be a small number compared to this one. Always by comparison, yeah. Okay, going to be a really small number. In fact, in this one, an extraordinarily small number because that is way less than 1 mole. Okay, so when I divide those two, I'm going to have 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. It's going to be like 9 1,000ths of a mole. Okay, it's going to be really, really small. Okay, so 5.42 E21. Okay, close the brackets, divided by Avogadro's number in its own set of brackets, E23. Yeah, 0.009, okay, moles. That is really, really small. All right, so it's a very small amount of this stuff. Okay, so I'm just going to write that down, 0.009 moles. All right, now I've got number of moles and I've got big M. I should be able to get little m now by simply multiplying both sides by big M. So I'll take my 182.71 grams per mole and multiply it by 0.009 moles. The moles will cancel and I'll be left with grams. Okay, so it ends up, I only have 1.64 grams of this stuff. And that makes sense, because according to my numbers, I didn't have very much of it, okay, in terms of like the number of molecules. I say not a lot of molecules. It's still a gargantuan number, okay, but in terms of the actual physical amount I have in front of me, it's not very much, okay? 1.6 grams would be like the mass of 2 raisins, okay, something like that. Like it'd be a really small amount. Okay, now what I see oftentimes on quizzes and tests with the mole equation is people second guessing their numbers. Okay, remember, we're dealing with really big numbers and sometimes also really small numbers like this. Okay, and sometimes it throws people off when they get a number like this and then they second guess their math. Okay, if you're getting to a point where you're like, oh, I don't like that, really just think it through. Okay, ask yourself, what was that number? How does it relate to this number? I know I did the math, like I know I was supposed to divide them, so it's okay that I got this number. Okay, you sometimes have to reassure yourself a little bit by just talking your way through it. Okay? All right, questions on those? All right, so as I said, this week, we're gonna go over 4 different ones each day. So you'll have 4 solved examples from each day of this week, okay? And then this Friday's quiz will be on the mole equation. Your practice quizzes for this week, 15, 16, and 17. Okay, so you can try those in the evening, okay, or whatever, and then watch the video and see if you get them right. And then you can come in and ask me questions if you don't, but this week is just gonna be mole equation. All right, and then next week is your exam. Okay, so it's coming right up. What I will probably do today is post the unit exam review materials in Google Classroom, okay, in case anyone wants to start looking at that, okay? It will include a practice exam. Don't do the practice exam first. Do it last, okay? Like do it on Sunday and then you can see how you're doing. Because if you do it first, all it's going to tell you is you probably need to study a little bit more. Okay, so you want to do it after you've done some active studying already, okay, and then it can fine tune the studying for you, okay? So if you're looking, because I'll give you the key to it, okay, and you can look it through and go, okay, I didn't do very well on naming questions, I guess I got to work on that a little bit, okay, or I did poorly on balancing, okay, I got to work on that. Then you know exactly what you have to work on, okay? If you do it first, all it's going to tell you is you got to work on everything, and then it's a wasted exercise. Okay, so I know it's tempting, but leave the practice exam until you've done the other stuff that I include in the review package. There's more questions with the answers, okay, for you to try and practice. Okay, use that exam last. Okay, then it can really help you to figure out what you've got to work on. Okay? All right, I would like you guys today, we did a few of these yesterday. Sorry guys, I gotta find the questions I want you to work on. If you have the workbook, you can pull that out. The ones I'm gonna have up here are in the workbook. Okay, I'd like you guys to do 1, 2, and 3. Here's how 1, 2, and 3 are different. They have a little story that goes along with them. It's just there to distract you. Okay, are these still going to include n, little m, big M, and Avogadro's number? They do. Okay? It just challenges you a little bit to read the story first. The reason we do that is, going forward and over the last 10 years, the diploma exams for all the sciences have started telling stories. Okay? They'll have like a page of text for you to read, and then like answer these 2 questions using this page of text you just read. So what we're starting to do as early as grade 10 is start giving you story questions. Okay, so that you get used to reading through a bunch of distracting material and you can glean what you need from that. Okay, it's an important skill that we're starting to see more and more, so we're working on it earlier and earlier. So that's these are kind of the start. They're not very long stories, obviously, okay, but we once saw one on the Physics 30 diploma exam that was a page and a half of text to answer 2 questions. Okay, it was like, what a waste of time. But I don't make up the test, but I have to prepare you for it. Okay, so try these 3. Let's see how we do. Okay. Okay, let's real quick look at question number 1. What type of question is number 1? It's a type 2 question. We're looking for mass, and we're being told the number of moles. Okay, so if we read through this question, this whole first sentence is utterly useless. Okay? It isn't there to do anything but distract you. Okay? I mean, in the metallurgy of iron, iron 3 oxide is converted to iron and carbon monoxide by reacting the ore with coke, pure carbon. Yay. Doesn't help me answer this question. It's just there because I wrote it. Okay? So, how many grams of Fe2O3 are in 0.580 moles? Okay, so I can get big M from this, and this is N. Agreed? Okay, I had to read a story first, but now I've got those 2 pieces of information. N is 0.580 moles, and I'm looking to calculate the molar mass of this stuff. So that's going to be 55.85, that's my iron, times 2, plus my 3 oxygen, 16 times 3. Okay, 159.7 grams per mole. All right, so I've got N and I've got big M, and I'm trying to find mass, little m. What do I do with big M? Multiply it over to the other side, right? Okay, so now that's done. Now I just plug in my numbers. 159.7 grams per mole times 0.580 moles. Okay, moles are going to cancel, and I'll be left with grams. Okay, 92.63 grams. Okay. In the end, was that any more mathematically challenging than it was when I just wrote that last sentence all by itself? Not really. Okay. It just means you have to pull some of the information out of a story. That's all. Okay. How many people have done number 2? Okay. So for number 2, it says we're talking about butane, C4H10. Okay. What mass of butane would be in 4 moles? Okay. What do they give me there? N, and the ability to calculate big M, because it's butane. They told me it's C4H10. All right, so if I want to do that one, all right, I just go, all right, big M is going to be 12.01 times 4 plus 16 times 10. Okay, so 12.01 times 4 plus 160. Okay, 208.04 grams per mole. Okay, and they told me 4 moles. So they,
Is it 16? Is it in hydrogen?
oh, sorry, it's hydrogen. Good catch. Coder's not with it. Okay, and that. 1.01 times 10, which would be that much, 10.1, right? Okay, so 10.1 plus the 12.01. Okay, let's do that instead. So 12.01 times 4, that number's right, okay? Plus 1.01 times 10, okay, all right, better, 58.14, better, okay. 58.14 grams per mole. Okay, and when they told us the 4.0 moles, they gave us N. Yeah, little n, right? Number of moles. Okay, so that's going to be 4.00. Is this the same calculation we just did? It's also a type 2 question. Okay, I'm given number of moles, I'm given the material. Okay, n equals little m over big M. Multiply both sides by big M. 58.14 times 4 moles. Okay, well, should be 232.56 grams. Okay, how many people have done 3? All right, I'm going to give you a couple minutes. I want to do 3 before the bell goes. So I'll give you 2 more minutes on number 3, and then we'll go through it. So we're just dealing with phosphorus, which is not a compound, it's just an element. Okay, so I know I have 77.5 grams of that, and I know that the molar mass of phosphorus is 30.97. Okay, I don't have to do anything special with that. 30.97. Okay, can I get the number of moles? Okay, what do I do with the number of moles once I have it? Multiply it by Avogadro's number, right? Okay, so n will be the 77.5. Okay, little m divided by big M. Okay, 30.97. Okay, there's my number of moles. Multiply that by Avogadro's number. Whoop, and I forgot to put it in brackets. That makes a difference. Okay, and we get 1.51 times 10 to the 24 atoms. Why do I get atoms? Because it's an element, yeah. Okay, now, does phosphorus come as single atoms, or does it come as a molecule of 4 atoms? It comes as a molecule of 4 atoms, but that's not what the question asked. The question asked, how many atoms are there? If I wanted to calculate the number of molecules, I divide that number by 4. Yeah, okay, sometimes that happens with elements like that. Okay, all right, we'll continue to work on that tomorrow, guys. Good job.